the things we did yesterday. Okay, 6.4, we're going to talk about inverse functions. First period assured me that you hadn't seen this in your algebra before, so this is a new thing. If I have a function, we'll start with this nice g of x equals 3x minus 5, and I want to find the inverse function. First of all, tell me, what does that function look like? If I were to graph it, what's it look like?
A line.
A line.
That has a slope.
What? It has a slope of 3.
And crosses through negative 5 on the y-axis.
You guys are good. You remembered. I'm proud of you. Good job. Okay, so now to find the inverse function, I'm going to give you a set of steps. First off, if it's given to you in the function notation with the g of x equals, you're going to replace the g of x with y. Because we're going to be doing some manipulating around, and that y is way easier to work with. Second step, you're going to interchange the x and y. An inverse function happens when the x and y change places. So you're going to switch where they're at. So when I write this will be the inverse function. Where there's a y, I write an x. Where there's an x, I write a y. So this is.
Are you ever going to have a problem where there's more than one x or y?
I don't think today we will. Okay. So this is the inverse of this. I switched the x and y. Now the next step, we want to look at it in our standard form, so we need to solve for y so we know what it looks like when y equals. So you guys know how to do that. We're going to add 5 to both sides. And we divide by 3. So I get y equals x plus 5 all over 3. That is it. So this function and this function are inverse functions. Okay? So to find an inverse function, you interchange the x and y. Questions on the basic idea? Okay? So let's do a couple of these. So we've got f of x equals 12x plus 7. What will be the first thing that I do?
I wanted to see.
Put the y in for the f of x. Next thing. Swap the y's and the x's. So I get x. Now solve for y. So we subtracted 7, we divide by 12, and we get y equals x minus 7 all over 12. Now, on your assignment, sometimes they'll write these functions this way. They'll say 112 x minus 712. These mean the same thing. What you're doing with them is going to depend on which way you want to write them. Okay? If I wanted to graph this way would be better, right? Because I could look right at it and say, okay, my slope is 112. My y-intercept is negative 712. Got it.
Well, we're not going to graph today, right?
Not today. We say that for Monday. Okay. If you're going to multiply this by something, the first form is the better one. So depending on what you're going to do, it's going to depend on what form you put it in. Okay, this next one, we're going to do the same thing. first step, why we put in the y.
So
Next
swap-
step, we swap the x
but
and y.
is it gonna be x cubed equals, or is it gonna be 2y cubed plus 1?
We're going to, yeah, you just exactly switch the x and y. So that's a good question. That's okay, that's a good question. You exactly switch it. You don't take any of the other, anything times that are with the x, it's just x here, and the y where the x was. Now we have to solve for y again. So we minus 1. So I get x minus 1 equals 2y to the third.
To the blue.
Now divide by 2.
Divide by 2. And I have x minus 1 over 2 equals y to the third. So I need to find a cube root. It's either write it as a cube root or raise it to the 1/3 power. Remember, those mean the same thing.
So you're gonna do
You get y equals x minus 1 all over 2 to the 1/3 power.
And we don't solve that.
And that is solved. Or you could write it this way. X minus, the cube root of x minus 1 over 2. These are equivalent statements, just written with different notation.
How do I get back to y equals mx plus b?
That one is, would you put that one in y equals mx plus b form? Couldn't do it. Because
it.
is that a
It's just
line?
not possible.
That's not.
Come on, follow me.
Hey, times.
If it has an exponent, it's not a line.
Oh, okay.
That's why it won't go. That's good you noticed
Can
that.
we do the next one in green?
Green is the next color?
Yeah.
Okay, I'll do that just for you.
Sweet.
Okay, one more thing you have to do on your assignment today. If I have two functions and I want to verify that they are inverse functions, we're going to use composite functions, like we did for today, to do that. I'm going to find g of h of x. Okay, so here's my x. Here's my h of x. I'm going to put it in for the x. Now, before I even start, I'm going to be multiplying this whole thing by 4. So rather than write it in this form, I'm going to combine it into that form. X minus 9 all over 4. This makes my life a little bit easier. Okay? So, do you see that worked?
Yeah.
Do you see why I did it?
Yeah.
Because here, if I multiply 4 times 9, x minus 9 over 4,
It's
those
just
cancel.
x minus 9.
So I get x minus 9 plus 9,
And this is gonna be,
That's 9 cents.
which equals x. Now here's the deal. If you have inverse functions, if you take their composition, it will always be x. Always. So in the section of the problems that says verify that these two functions are inverses, you need to show the work, and you should get the answer of x. If you get something else, you did something wrong somewhere, because all the ones in that particular section are inverses. Okay, so that's a good check for yourself to see whether they are indeed
Are there going to be
inverse.
ones on there that says tell whether they are, so you can have a yes or a no?
This is
Not verify, but yeah, verify means like you're checking to make sure it is, but
okay.
who, what, when, where, how.
it's just simple